Welcome back, students. Today we are going to see another chapter from numerical methods and probability theory. So today's chapter is probability theory. So this is the unit 4 of probability theory. So in this chapter we are having different definitions based on probability. So probability, what is the definitions on probability, what is the probability axioms of probability, and addition and multiplicative laws, and what is the conditional probability, what is the Bayes theorem, and what is the random variable, and what are the different types of random variables. So these are some of the important concepts we are going to learn in this probability theory. So now we are going to start this. So what is the definition of a probability? We already know that chance plays an important role in human life. So everyone expect a chance of chance. Everyone expect a chance. So chance is nothing but it is probability. For example, if we take, we can take plenty of examples on describing this probability. Suppose a farmer can expect a chance of raining. He expect a chance of raining, or a army chief can estimate the change of destroying the strategy of an enemy. Or we can simply say that it may rain today, or there is a 50-50 chance of a train will come at the right time. Or otherwise, a student may say that I will stand first in examination. He will stand first in examination, or second or third, or he may fail. So everything, whatever we take, so still morning to evening, night, by night we are using this probability knowingly or unknowingly. So every day we are using this probability. So probability is nothing but we can simply take it as chance. So here what he has said is, even though there is lot of experience and logical thinking, but behind these expectations, one needs an appropriate measure. For this purpose, the probability has been originated. So here we say that even though it is having lot of experience and it is having lot of logical thinking, but behind these expectations, one needs an appropriate measure. For that purpose, the theory of probability has been originated. So the word probability means chance of occurring of a certain event. So it is the word probability definition. Next, the concept of probability is used by each one of us knowingly or unknowingly in our day-to-day life. So this is already we know that. The theory of probability is one of the most useful and interesting branches of the modern mathematics. So it is very interesting and very useful in modern mathematics. It is prominent by its applications. It is used in many applications, such as it is used in insurance, it is used in statistics, it is used in biological sciences, it is used in physical sciences, engineering, etc. So it is used in various fields. So this probability is used in various fields. So theory of probability. So what is the definition and what is the theory or what is the principle of a probability? So the theory of a probability says that it is a branch of mathematics or it is a branch of a science which deals with the estimation of chance is called as theory of probability. So simply we can say that what is the theory of a probability means, or what is the principle of probability means, simply we can say that it is a branch of a mathematics which deals with the estimation of chance. It is called as a theory of a probability. So mainly this probability origin is in gambling. So the three best examples of probability are, so one is playing cards. We already know that we are having 52 playing cards. And another one is tossing coin. We already know that when a coin is tossed, then we get two outcomes, that is one is head and one is tail. And playing dice, we already know that die is having the 6 faces. So these three are the best examples of probability. So this probability is popular in 17th century in France. So if anyone asks when it is popular means, we can simply say that it is popular in 17th century, and where it is popular means it is popular in France. So the probability was popular in 17th century in France. What are the three best examples of probability? So there are three best examples of probability. Number one is tossing a coin. We already know that it contains head or tail. Number two is rolling a dice. It contains 1 to 6 faces. Next one is playing cards. We already know that it is having 52 cards. Next, some mathematicians or statisticians have participated in developing this probability. So now we are going to see some of them. So number one is the Italian mathematician. So his name is Galileo. So he was born in 1564 and he was died on 1642. So he tried to derive the quantitative measures. He has derived a measures for sake of dice when it is rolled in gambling. So this is the participation of Italian mathematician Galileo. So next, the foundation of probability. What is the main foundation of probability was laid by Pascal and Fermat through letters and discussions. So those days there were no net facility, there was no mails, or there were no WhatsApp, or there were no Twitters, etc. So in 16th century, so here the Pascals and Fermat they wrote, they whatever they know, they whatever the knowledge they have based on probability. So they have discussed through letters and discussions, and they have to go, they sit on a place, they sit on a clubs, and they exchange their votes based on the problem. And the Huggins was a Dutch mathematician, and he published the first book on probability. So the first book on probability was published by Huggins. He was a Dutch mathematician. Next, Jacob Bernoulli. So he also applied the theory on other branches of mathematics. So he applied this statistical theory for other branches of math. So these are the some of the few persons who has developed the statistics. So probability and statistics. Next, we are going to see what is the definition of a probability. So the definition of a probability is simple. It is P of A equal to M by N, where M represents number of favorable cases and N represents total number of cases. So if anyone asks what is the definition of probability, means simply we can say that probability of A equal to number of favorable cases by total number of cases. So it is the definition of a probability. So next we are going to have some definitions based on this probability. So here we are defining some terms based on the probability. They are, number one is random experiment. So what is a random experiment? Random experiment means an experiment whose outcome is not known in advance is called as random experiment. That means we cannot say that it is its outcome. We cannot say its outcome, whether it is true or false, or whether it is head or tail, whether it is 1 or 2 or 4 or 5 or 6. We cannot say its outcome, and in advance it is called as a random experiment. So the best examples of this random experiment is lifetime of a human being. So it is the best example of a random experiment. Next, a probability is a study itself. It is a study itself of a random experiment. So in tossing a coin, one is not sure whether head or tail will occur. So it is a random experiment. In throwing a die, one is not sure whether 1 or 2 or 3 or 4 or 6 will obtain. It is a random experiment. So best example is lifetime of a human being. Lifetime of a computer system, we cannot say how many years it will be. Next, taking a pack of cards, one is not sure whether which variety will come on the cards. So these are some of the examples of a random experiment. So simply we can say that random experiment means an experiment whose outcome is not known in advance is called as random experiment. So the next important definition is sample space or probability space. So the definition is the set of all possible outcomes of a random experiment is called as a sample space. It is denoted by capital S. So if we take one example of tossing a coin. So in tossing a coin, there are only two outcomes. That is, one is head, another one is tail. So if you throw a die, or if you rolled a die, then it is having only 6 faces. That is 1 or 2 or 3 or 4 or 5 or 6. So no other cases will come. So this is the definition of a sample space or probability space. So each element of a sample space is called as sample point, and it is denoted by small s. So the sample points are denoted with small s. Next, trial. Trial means conducting a random experiment is called as a trial. Simply we can say that conducting a random experiment is called as a trial. So rolling a die is a trial, or tossing a coin is a trial. Next definition is event. What is an event? An outcome of an experiment. That means the result of an experiment is called as event. Suppose if you toss a coin, then the result may be either it is a tail or it may be a head. Or if you throw a die, then the result may be it is a 1 or 2 or 3 or 4 or 5 or 6 will come. So we are having an important formula in tossing a coin. So that formula is, if a coin is tossed n times or n coins tossed at a time, then the sample space contains how many elements? Means it contains 2 power n elements. So if a coin is tossed 2 times, then it has 2 square that equal to 4 elements. So that is head head, head tail, tail head and tail head. If a coin is tossed 3 times, then it is having 3 possible outcomes. That is head head, head tail head, head head head, head head tail, tail head head, head tail tail, tail head tail, tail tail head and tail tail. So the formula for tossing of a coins, when a coin is tossed n times, is 2 power. Next, the formula of a die. When a die is rolled n times, or n times, or die is rolled 2 times, when a die is rolled 2 times, or 2 dice rolled at a time, then the sample space consists of 6 power n, that equal to 6 square, that equal to 36 elements. It contains the 36 elements. So next, the other definition is exhaustive events. So the exhaustive events means the total number of all the cases is called as exhaustive event. That means if you take a tossing a coin, then the 2 cases are head and tail. If you roll a die, then the 6 cases are 1 or 2 or 4 or 5 or 6. So these are the definitions on probability. So thank you students, thank you very much.